Hello everybody, today we're going to be doing our notes on the second kind of variation, and that's called inverse variation. So, before I even start, inverse variation doesn't really affect you as much as direct variation. Like, direct variation is a graph of a line, and we're going to be dealing with that kind of stuff throughout the entire year. Inverse variation looks a little different. You still need to work with the equation and word problems and stuff like that, and like tables and all that fun stuff, but you're not gonna have to worry about graphing or trying to come up with the equation from a graph so much. And then you'll see why in a second. So let's go ahead and learn our first vocab word, which is inverse variation. So inverse, ooh, this is very big. Inverse variation is an equation of the form y equals k over x, that backslash is supposed to be like over, so k over x, where k does not equal 0, with a constant of variation k. So k is still a constant of variation for our inverse variation. Okay, it's still representing the same thing. We find it a little bit differently with inverse than compared to direct, but it all means the same thing. So you might have noticed that the equation for inverse variation is very, very similar to direct variation. You need to be very, very careful about how you set up your equations. Remember, these equations are not on your formula sheet, so you need to have these memorized. Okay? So let's go ahead and take a closer look. Oh, we'll look at the graph. This is what a graph of the equation of an inverse variation looks like. They're two curves that never actually cross the x or y intercept. Or not intercept, x or y axis. So you will need to know what this graph like an inverse variation looks like. You will not have to actually graph it yourself. Okay? So don't worry about that. You do need to know what it looks like though. So if they give you 4 graphs and ask which one is an inverse variation, you should be able to do that. Okay? Alright. Now let's look at the formulas a little bit more closely. So inverse variation formula is y equals k over x. Okay? So the way I like to think of it is like almost like an inverse operation means kind of, it gets me thinking about reciprocal, so I think of a fraction when I think of inverse, kind of. So that's what I think of here. You might think of something else. That's totally fine. I'm sorry if I'm confusing you now. That's just how my brain works. But I think the hardest thing about this whole thing is making sure you are able to recognize that what an inverse variation formula looks like and what a direct variation formula looks like. Okay, and using the right one. Alright, so make sure you take very, very careful about these formulas, okay? And take care of them. So the constant of variation of inverse variation, it still means k, but we find k from this formula a little bit differently. So instead of dividing by x like we do with direct, we have to multiply by x to get it out of the denominator. So k is actually found by multiplying x times y. And just like with direct was a certain ratio. With inverse, it's always going to be a certain product. Like k is always going to represent a certain product made from the two coordinates of an ordered pair. So again, it's really, really very specific kind of like function, basically. Okay, so every ordered pair will give you the same k, just like with direct. Alright, so let's go ahead and try some problems. Example 1, identify if it's direct, inverse, or neither. Okay? So just like with direct, we're going to have to get y by itself here. So we have to go ahead and subtract 2x from both sides. So now we have 3y equals negative 2x plus 5. Now we have to get y by itself, so we divide both sides, like everything, by 3. We end up getting y equals negative 2 over 3x plus 5 over 3. Now that does not look like our inverse variation, and it doesn't look like our direct variation because it has this y-intercept. Okay? Hopefully you notice the inverse variation doesn't have a y-intercept either. Okay? So anything with a y-intercept is not a direct or inverse variation. Alright? So now you're going to go ahead and try these two on your own. When you come back, I'll have answers for you. Hopefully. Yep, I do. So remember, you're still trying to get y by itself for both of these. Okay? So go ahead and try, put the video on pause. When you come back, I'll have answers. Good luck. Okay, so looking at this one, we had to get y by itself, so we'd have to divide both sides by x, giving us y equals 3 over x. That is our inverse variation. Okay, whenever you have a number over x, that's an inverse variation. Here, to get y by itself, I would multiply both sides by 4, leaving me with y equals 4x, which is what a direct variation looks like. Okay, anything where you have to, when you have a number times x, or x is divided by a number, that's direct. Alright, example 2, identify the tables as a direct variation, inverse variation, or neither. I will say this probably has the most work you have to do, but it's not hard work. It's a little tedious, because there's no way to tell if something's like direct or inverse just by looking at it. You'd actually have to find k for the tables, just like we did with direct. So, and just because it's not direct doesn't mean it's automatically inverse. So you have to pick one of the variations to try first, like find the k for it with that kind of variation. If it doesn't work, try the other one. If it doesn't work for both of them, then you know it's neither. Okay, so first we're going to go ahead and try direct. And remember, that's going to to find k, we have to do y divided by x. Okay, so k equals 1/2 divided by 4, which gives me 1/8. The next one, I do k equals 1/3 divided by 6, and gives me 1/18. So because these k's are not the same, I know it's definitely not direct. Okay? So now we're going to go ahead and try inverse. So to get k for inverse, we just multiply the x and the y. So k equals 4 times 1/2 gives me 2. K equals 6 times 1/3, it gives me 2. So far, so good. And then the last one, k equals 8 times 1/4, gives me 2. So because they all have the same k, I know that this isn't inverse, because all the k's match. Okay? So you're going to go ahead and try B and C on your own, and when you get back, I will have an answer for you. Oh, sorry. And A, that would be the formula, y equals 2 over x. Or the equation, I mean. Okay? So go ahead and try this on your own, and if you want to take it a step further, then go ahead and try to make your equation as well. I think I have equations. Yeah, I do. Okay? Alright, good luck. So, now you've done B and C. If you look at B, so you had to pick one to start with. Didn't really matter which one you wanted to start with. But when you do it, you actually end up not getting the same K for direct, and not getting the same K for inverse either. So this one, B, is actually neither. Okay? C, you go ahead and start whichever one you wanted to start with, and do it. You see if you get the same K. I'm sorry, I'm trying not to give out the answer, but I might as well just give you the answer. So the answer would be direct, because the K we get for each one of these when we do y over x, we get 2. So y equals 2x is our equation for this table. Okay. By the way, if you ever see like a 0, 0 in there, you automatically know it's not inverse, because inverse does not go through the origin. And when you are finding k for it, 0, 0 is always going to use 0 for the k, so it doesn't really help you. So if you see 0, 0 in there and you're still trying to test to see if it's direct, just skip over that ordered pair. Okay. Example 3. So this one actually came off, I think, of an e-cart, which means it could be on an SOL. These kind of questions are on an SOL. This is a word problem. Okay? So the volume V of a gas varies inversely as the pressure P on it. So first clue was they told you it was inverse. It varies inversely. It's an inverse variation. The second thing, they didn't use X or Y in this whole thing. So you have to identify what is your X, what's your Y. Well, if you remember from direct variation, when they said varies directly, it was always the Y in the front. So this is the thing that's varying. This is the part that the volume is depending on the pressure. So volume is Y, and the pressure is the X. It's the direct variation. Or, I'm sorry, it's the independent variable. The pressure is the independent variable, while the volume is the one that changes depending on pressure. So that's oh my gosh. That's the dependent variable. Okay, so that's good to know. So we know X is our pressure and Y is our volume. If the volume is 240 under the pressure of 30 kilograms per centimeter squared, what pressure has to be applied to have a volume of 160 centimeters cubed? Okay? So we know it's inverse, we know what x and y is representing, so we know we're using the equation y equals k over x, but I'm just going to change it a little bit to actually apply it to this situation and put in the v and the p. So v is for my volume, which is y, p is for the pressure, which is my x. So v equals k over p. Alright, now I have the equation, but I don't know what k is. Luckily, they did give me a volume and a pressure that I know works for this situation. They told me that V is 240 when the pressure is 30. So I'm going to go ahead and plug that in. I'm going to scroll down just a tad. I plug that in, and I'm going to solve for K. So I need to multiply both sides by 30 to get K by itself. So 30s will cancel out on this side. 240 times 30 gives me 7,200. So yes, it's a very big number. Okay. So now my formula, or my equation for this situation is V equals, the volume is going to equal 7,200 divided by the pressure. Okay? So they're asking me what is the pressure, P, that has to be applied in order to get the volume of 160. So I know V is 160, plug it in. Now I got to get P by itself. In order to get P by itself, I first need to get it out of the denominator. So I'm going to multiply both sides by P. Just to get it out of the denominators. Now I have 160p equals 7,200. So now I'm going to go ahead and divide both sides by 160 to get p by itself. I end up getting p equals 45 kilograms per centimeter square. Which makes sense if you think about it, because when you're applying pressure on a volume, you're actually compacting it more and more. So if we have a smaller volume than 240, it means we had to apply more pressure to it. Okay? So that's why the pressure was 45 kilograms per centimeter squared. Okay? So, alright. The last one is your try on your own. I didn't make it as wordy or as word problem-y because we're going to spend an entire day on word problems. Not next class, but after break. And working with that. So, yours is just if y varies inversely with x and y is 5 when x is 3, find x when y is 8. So you go ahead and do this on your own. When you come back, I'll have an answer for you. Okay? Go ahead and pause the video and good luck. I'll see you when you get back. Okay, so you should have gotten your formula when you first did this. You should get y equals 15 over x. So using that equation, you plug in 8 for y, and you're going to get x by itself. Again, you got to get it out of the denominator, so you need to multiply both sides by x, and then divide by the 8 with the y. So you get x equals 1.875. Never said it was going to be a pretty number. Okay? Or, I think that's 15 over 8. I think that's what it is. Yeah, 15 over 8. Okay? But that's it. That's how you do it. It's a lot of plug and chug. Biggest thing, remember, is the equations. So if you have any questions, please write them down. I'll be happy to answer them in class. Other than that, have a good day. I will see you guys in class. Bye. Wait, hold on. I gotta stop it. Okay, now. Bye. Bye.